Okay, in this last video on this particular set of problems showing how to evaluate limits numerically using a graphing calculator, we'll go on to problem number 7, and once again we'll use the table function and we'll also use the graphing function. So we have the limit as x approaches 0 of sine x over x. So we're going to do sine of x, close parentheses, divided by x, and we check to see that we're in independent ask, second table. We have some leftover values. Now again, we're approaching 0 this time, so from the left we're going to do negative 0.1, and that gives us 0.9983, and we'll go on to the next, negative 0.01, 0.99998, and we'll go to negative 0.001, and you can see that we're heading for 1. When I move the cursor up and over on top of that 1, it's not actually 1, it's 0.999, but for our purposes 59 should be sufficient. Now we'll go from the right side, 0.1. So we'll go ahead and move the cursor up, 0.1. You can see there we're at 0.99833. Next would be 0.01. We have it's exactly the same values as we were approaching from the right, which means this function is symmetrical about the y-axis. And finally we'll do 0.001, and we got 1 again, but as we move the cursor up and over onto the 1, we can see it's not exactly 1, but it's point and then with 5 or 6 nines. And for this one we can clearly see that we're heading for y is equal to 1 as x approaches 0 from the left and right. And so we record that the limit there should be 1. Now we'll go in and take a look at this graph. Again, I normally start out with zoom and then standard. We can't see too much there, so the next thing that I would try to do is zoom. After standard, I'd do zoom trig, which we can see a little bit better. Now we can see that in fact as it approaches 0, it definitely looks like we're heading up to y equals 1 at that point there. And so how would we make sure? We're just going to do a trace. So we hit trace, and let's see where our cursor is. It's right there around 1. So with a trace, it's not quite as good as the table function. We can't control how close we get, but you can see as we're moving closer towards 0 from the left, the y values are moving closer and closer to 1 on the right. Now at a certain point it's going to jump over that. Right now we're probably about as close as we can get to that. We go a little bit further and we're right on 0 where there is no value. So you can see there's no value of the function when x is 1, because sine of 0 is 0 and x is 0, so you end up with 0 over 0. So hopefully you're seeing this pattern here. In all of these cases, we're ending up with a function, with an expression that is 0 over 0 at a certain point. And that doesn't mean that there is an asymptote there. And the values are different in each of these cases. So we call this particular type of expression an indeterminate form. Just plugging in 0 into sine x over x gives us 0 over 0. It's not defined at 0, but what's happening around 0 we really don't know. We have to do some other kind of analysis, like using the graphing calculator. So if we continue with trace and over to the right side now, you can see that just to the right of 0, we're getting close to 1 also there. So hopefully this will help to solidify the skill on how we use a graphing calculator, both the table function and the graph function, to evaluate limits or estimate limits of expressions.